Friends, very good morning to everyone. We were dealing with various photo reactions. These are the reactions induced by light energy. You have seen about photo substitution, photo fragmentation, and whatnot. In continuation to this, today's subject of discussion is photo oxidation. These are the oxidation reactions which we see in organic compounds, which is influenced by light. Photolysis gives rise to free radicals, and these radicals which are formed induces the oxidation reaction. How is it? Let us look into it. The polymers, when they are irradiated with the UV light, it gives rise to free radicals. It undergo photolysis of homolytic type and gives rise to free radical. This free radical which is formed is the initiation for the reaction to occur. That's why it is named as chain initiation. The radical which is formed combines with the oxygen and give rise to peroxy radical. The peroxy radical, which is much more unstable, reacts with the polymer, abstract the hydrogen radical, which gives rise to ROH and the R radical. The R radical which is formed reacts with oxygen to give peroxy radical. And the peroxy radical which is formed reacts with the polymer, abstract the hydrogen radical and gives rise to R radical, and the process continues. And the propagation of the reaction takes place. That's why this is considered as chain propagation step. The ROO radical which is formed ROH, it dissociates into RO and OH. It branches to two different radicals. The RO radical and OH radical which are formed are both unstable due to its lack of electrons. That's why that react with the polymer, abstract the hydrogen radical, gives rise to ROH and R radical. Then OH radical which is formed reacts with RH, takes out the H and gives rise to water and the R radical. And that's why the branching in the polymer occurs. Thus, it is the chain branching step. After all the polymer what we have used completes, then the termination occurs by the combination of the radicals which are remaining. The ROO radical which is formed can combine together, dimerize to give the inert product, or it can combine with R radical to give ROOR, or R radical can combine with another R radical to give a dimer, and the chain gets terminated. This is all the mechanism involved in photooxidation. In photo substitution or fragmentation, we have seen that it occurs in three steps, that is initiation, propagation, and termination. Here, one more step has got added up. Let us look with this one example. I take a polymer, initiate by UV rays, I'll get the R radical. The R radical I'll react with a polymer. It hydrogen CH, it is flanked between the carbonyl and oxygen. Both are electron withdrawing. This is acidic enough to lose that hydrogen. And R radical is which is formed by the initiation by the light energy, takes away the hydrogenous radical and gives rise to polymer radical. The polymer radical which is formed will initiate the further reaction, and this come under the chain initiation. The radical which is formed over here reacts with oxygen to give corresponding, or if I consider whole molecules R radical, ROO radical. The ROO radical reacts with the polymer, take away hydrogen as a radical and gives rise to P radical and OOH, peroxy compound. The peroxy, this is propagation. This peroxy compound which is formed under the influence of UV light, it loses OH as a radical and gives rise to a carboxy radical. The carboxy radical which is formed undergo branching at beta position. Oxygen, alpha to that one carbon, the groups attached to it, the alpha carbon is the beta position atoms. There are three beta position in this. This is O, C and CO. One electron can move over here. The bond between the carbon and oxygen breaks. Another electron will be taken away by the carbonyl, and a carbonyl oxygen, CO oxygen and a carbonyl bond is formed, and it gives rise to a new oxy radical and the carbonyl derivative. The beta cessation has occurred. This is also beta position. The one electron can move towards the carbon, giving rise to methyl radical, and this remaining another radical combines with this oxygen and it gives to alpha dicarbonyl compound along with the methyl radical. Or this is also beta position, three beta positions. The cessation can also occur over here. One electron can move over here, another electron forms the bond with this carbonyl group, and I will get a carbonyl derivative and a carbonyl radical. This is branching step. After all the pH gets completed, it gets terminated by the recombination of the radicals which are formed and the chain termination occurs. This is how the oxidation occurs in the presence of light energy. This comes under the categories of photooxidation. And there are many other photooxidation reactions, and that will be the subject for the further discussion in the coming presentations. Till then, have a nice day.